Hello friends, my name is Chanchal Agarwal. In this video lecture, we are going to see bubble sort time complexity. So first of all, we will see the best case time complexity and then we will see the worst case time complexity. In the best case time complexity, let's suppose I am taking a sorted array. If I am taking this sorted array, so what is the upper bound that the bubble sort required to sort the sorted array? Okay, as I have told you in the last video lecture, this is the program for bubble sort. Suppose if I take a flag variable here, integer flag I am taking, and suppose I am taking this variable as 1. I am assigning the value as 1. As I have told you in the last video lecture, that it always start from 0, and if it have 5 elements, so it require 4 comparisons in the first pass. Okay, so that will be 0, 1, 2 and 3, so that will be less than n minus 1. This I have told you, and the and with increment of each passes there will be decrement in the comparison. So j value is starting from 0 and j value is decrementing according to I. Now we are comparing the adjacent element, that is j, and j plus 1th element. We are comparing. If j value is greater than a of j plus 1, so the statement I have taken here, if this element means smaller index have greater element, means the array is unsorted. Likewise, any of the element is unsorted. So first of all, it will do flag is equal to 0, then it will swap. Okay, I have done some modification in the program. So for this array, how it will work? First of all, if this value is j, so this value will be j plus 1. So it will compare these two elements, a of j and a of j plus 1. Flag value is 1 only. So if j is not greater than, here a of j is not greater than j plus 1, 1 is not greater than 2, so it will not go into this loop, means our flag value is only 1 now. Now the j value will be incremented, that will be 2 will be compared with 3. Okay, so this is not greater, so it will not go into this loop. Then 3 is not greater than 4, it will not go into this loop, and 4, then at last it will compare 4 with 5. Okay, so it will not go into this loop. If you don't know that how I am doing comparison, so please see my last video lecture of bubble sort. So in this the flag, at last the flag value is 1 only, because we have not entered into this loop. Okay, if any of the elements, suppose 2 would be greater than 1, so then only we can enter in this loop, but at last the flag value is 1 only. Now see here, as I have written, if flag value is 1, that means array is sorted. Means, as you can see, that we have not performed any of the swapping operation in this array, because we have checked all the indexes value, adjacent indices value, like this and this, then this and this, then this and this, and this and this. We have checked all the values and we have found that the smaller index have a smaller value only, and the greater index has greater value only. That means the array is already sorted. So if our flag is equal to 1, the array is already sorted. Means there is no swappings which can be performed on the array. Means all the values at a of j is less than a of j plus 1 only. That is array sorted. Hence we don't require to go on the second pass. In the bubble sort, if we have 5 elements, so we have 4 passes, but at the end of first pass only we get to know that there we don't need any swappings and array sorted. At the end of first pass only we get to know this. So why we go to the second, third and fourth pass? So we don't require any second pass. at the end of first pass, if there is n element, so there will be n minus 1 comparison. Means if there is 5 element, okay, if there is 5 element, so there will be 4 comparison. Okay, so if there is n element, so there will be n minus 1 comparison at the end of pass 1. And since we are not going to the pass 2, 3, 4, because at the end of pass 1 we get to know that all the elements in the array are sorted. So we take this part, that is best case time complexity for the bubble sort will be big O of n. Now what is the worst case time complexity for bubble sort? In the worst case, if we have element 5, so the first pass will require n minus 1 comparison. Okay, if we have 5 element, in the first pass we require 4 comparison, that is n minus 1. In the second pass it is required 3 comparison, that is n minus 2. And if we generalize this expression, so the second last pass will require 2 comparison and the last pass will require 1 comparison only. So if the first pass require n minus 1 plus second pass will require n minus 2, as and we add all these value, and the second last pass will require 2 comparison and the last pass will require 1 comparison. So it is the sum of first n minus 1 natural numbers, that is n minus 1 by 2, that is big O of n square. So in the best case we will execute only 1 pass, and after 1 pass we get to know that the array is sorted, so we don't require any other passes, that is second pass, third pass, fourth pass, and then last pass we don't require. So the first pass will require n minus 1, so the best case time complexity will be n minus 1. And in the worst case we require all the passes, so we add all the passes, and the worst case time complexity is big O of n square, and the best case time complexity is big O of n for bubble sort. Thank you friends for watching this video. If you like the video, so please click on like and subscribe button.